Alright, so today we're looking at lesson 43. We're dealing with tension problems with friction. A couple of weeks ago we looked at tension problems where we had frictionless surfaces, but these problems are going to be with friction this time. So hopefully you'll be able to do the tension problems dealing with friction. Do you remember doing this type of problem before, where we had a frictionless surface and we just had to set up our equations and then solve for our T, our tension, and our A, our acceleration? On our block M sub 1, it is sliding below, and we had frictionless surfaces, and so the only horizontal force acting on it was the tension that was in the rope. And that's what we looked at before. We also dealt with ones on an inclined plane where we had no friction. And so we had two different forces that were acting on our block M1. One of them was the tension in the rope, and then the other was the component of the weight that is acting down on the plane, which is the mg sine of some theta, inch apart. Of the part that we're pulling it back down the plane. So those are the types of problems that we've already looked at. And now we're going to look at some ones dealing with friction. If you have surfaces that are not frictionless, then you're going to have an additional force on both of your blocks. And that force is going to be the force of friction. So now we're going to be adding friction into our problems. So let's look at it again. We're going to start with two blocks where they are on, one is on a table and then one is coming over a massless, frictionless pulley. And so we're going to set these up. We're going to start with a 3 kilogram block. Fill in all of our information that we can for that block. So I'm going to start by drawing a little diagram for this. We've got the tension that's going this direction towards the rope, tension in your rope, and then acting opposite the tension is the kinetic friction. And remember, S sub K equals mu sub K F sub K. So those are in opposite directions. You have your weight, which is your mass times your gravity, so the 3 times 9.81 is acting down, and then our F sub n is acting in the opposite direction. So our horizontal forces, since we have it moving, the sum of the forces is going to equal the mass times the acceleration. And so, in this example, we have our tension is one horizontal force, and then the other horizontal force is the F sub K. We know that it's moving over the frictionless pulley, going to the right, so the tension is going to have to be greater than the kinetic friction force for it to move. So that's why we're subtracting it. So T minus F sub K is going to equal mass times acceleration, which you can also write as mu sub K F sub n equals mass times acceleration. Those are your horizontal forces that you have there. You also have vertical forces for this block. The only vertical forces you have is F sub n and mg, and they equal each other. Otherwise your block would either be going away from the table or falling through the table. So those are your forces there. Now what we're going to do is fill in the information that we were given. We don't know our tension, that's what we're trying to find. Our mu sub K was 0.80, and our F sub n is just 3 times 9.81. And then our know the acceleration. And now this equation right here, we don't necessarily need it for this problem because they told us what our mass and our gravity are, so we can easily find our F sub n. But it's possible that we may need to find some of that information for another problem in the future. So we have this equation here. I'm going to box it because we're going to need it in a little bit. Now let's look at the 5 kilogram block. We only have 2 parts that are acting on it. The tension that is acting up, and then the weight, which is your mass times your gravity, is acting down. The sum of the forces is going to again equal the mass times the acceleration. On this one, since the block is falling, we know that the mg has to be greater than the tension. So you're going to do the mass times the gravity minus the tension. And then you're going to equal that to your mass times acceleration. So the tension force is less than the weight, that's why you're subtracting it. If the tension force was greater, then your 5 kilogram block would be going up. And since it's falling, that means your tension has to be less than the weight. So now we're going to fill in the information. Our mass is 5, the gravity is 9.81. We don't know our t, and our m is 5, and we don't know our weight. So now we've got these 2 equations, and we can solve them for our tension and our acceleration. So if you multiply this 0.8 times 3 times 9.81, you're going to have t minus 23.544 equals 3a. And I'm going to solve for t. And then I'm going to plug that into this equation down here. 5 minus 3a plus 23.544 equals 5. So you need to distribute your negative sign across your parentheses and multiply those 2 numbers. So add your 3a and 8a, and if you subtract those numbers, you get 25.6. And solve for a, you should get that number, 3.18825. Now let's look back up here at the problem. We have 2 sig figs, 3 sig figs, 3 sig figs. So our answer needs to have 2 sig figs in the final answer. So we would take our 3.18 and make it 3.2 meters per second squared because it's acceleration. And our block is moving to the right. So that would be your answer for this example. Alright, so let's look at the next example. We have 2 blocks connected by a massless, frictionless pulley and rope, but it's on an incline. So again, we're going to start with 2 blocks. We're going to separate them out. I'll start with a 9 kilogram block. We want to go ahead and draw our free body diagram. So we know that the tension is acting from the pulley along the rope, so we can put our tension in. The force of the friction is also acting in the same direction. And that's because our block is sliding down the lane, so it's got to be acting in the opposite direction. So F sub K equals U sub K F sub N. We also have our weight that is acting straight down. is actually straight down. And we can split that up into two components. Using our triangle. We have a right triangle here, C3 angle. And the part that is going this direction is our f sub x, which is m times b times the sine of 60. And then we have the part that's acting this direction, which is our f sub n. And it's noted by mg cosine of 60 degrees. So if we sum our forces that are parallel to our incline, we have equal to mass times the acceleration. Now the force that is the biggest is going to be the f sub x because it's going down the plane. So we're going to start with f sub x, and then it is subtracted by the tension and the f sub k. Both of those are slowing your block down. So the f sub x is your mg sine of 60. We don't know the tension. Your f sub k is u sub k f sub n. And that equals the mass times acceleration. Now I will point out that your f sub n is mg cosine of 60. So if you want to fill that in, your formula you can. Now if we plug in all of the numbers, our mass is 9, our gravity is 9.81, sine of 60, minus t, and then minus our u sub k is 0.18, our m is 9, our g is 9.81, and we have cosine of 60, and our root, and then our mass is 9, and our acceleration is 8. So that's all for the 9 kilogram block. Now if we look at the 6 kilogram block, we have the tension that's acting along the rope, going up, and then we have our weight, our mass under gravity, is acting down. So for the 6 kilogram block, the sum of the forces equals mass times acceleration. Now on this one, the block is going up. So that means that the tension is going to be greater than the weight. So T minus mg is going to equal mk. And so we don't know our T, we know our mass is 6, gravity is 9.81, and mass is 6, and then the acceleration is 9. And if you solve that for T, you get 6a plus 58.86. So now we can plug that in over here, and we can solve for our acceleration. So 9 times 9.81 times sine of 60 should be 76.46 with some more decimals behind it. If you did not get that number, that means your calculator is probably not in degrees. So minus 6a and then minus 58.86 because you have to distribute that negative right there. And then if you do 0.18 times 9 times 9.81 times the cosine of 60, you get 7.9461. That equals 9a. Now we can add 6a to 9a to get 15a. And then if we combine the numbers on our left, we have 76.46 and minus the 58.86 and minus 7.9461. We get 9.655 and then it's some more decimals after that. And then divide by 15 and you end up getting that your acceleration is 0.6436. I'll round up from there to a 9. We're going to have two sig figs because we have a 0.18 there. So this is going to go to 0.64. And since it's acceleration, the units would be meters per second squared. And our blocks are going down the plane. So we put down the plane. So that would be your answer there. So you want to start off by setting up your equations for each block separately and then combining them to solve for your T or your A. Notice that neither of these problems ask you to find the tension in the rope. The previous problems that we worked with where they were frictionless did ask for that. But if you were supposed to find the tension, then you can easily just plug it in here, plug in your A, and you can solve your tension. So if it asks for it, that's what you would do there. Okay, so homework is to do 1 through 20, and then make sure to look at the curveball questions, and we can go over them tomorrow if you have any questions.